Okay, so I've included a few of the solutions to some problems from your homework from Wednesday. First one is 13. So we want to eliminate the fraction, and since we only have one fraction, we're going to multiply by its denominator. Multiply everything by a, and we end up with a squared plus 1a equals 6, because the a's in this fraction here are going to cancel out. Okay, so now we solve it. The easiest way to do this is to set it equal to 0 and see if you can factor. So a squared plus 1a minus 6 equals 0. Can I think of two numbers that multiply to negative 6 and add up to positive 1? Well, if I use a plus 3 and a minus 2, 3 times negative 2 is 6, and 3 plus negative 2 is 1. Now we just set each factor equal to 0 and we'll get our solution. So a plus 3 equals 0, a minus 2 equals 0, and that means there's two solutions. A could be negative 3, or a could be positive 2. Both would work in the original equation. The next one I want to go over is 16. This one gets a little more complicated than the rest. So we have, for our denominators, a y plus 2, a 2 minus y, and then a y squared minus 4. So because this is a difference of two squares, we should factor it into y plus 2 times y minus 2. An issue that we run into here is that these are the two factors, and I see the y plus 2 in this fraction. This one here, I want it reversed. Instead of saying 2 minus y, I want it to say y minus 2. So to do that, we're going to add the opposite. So instead of subtracting, we can add the opposite of the value. And you can put that opposite either in the numerator or denominator. In this case, I'm going to reverse the denominator. So instead of subtracting 2 minus y, we could say that's the same thing as adding y minus 2. Okay, so now here's what we have. We have 2 over y plus 2 plus y over y minus 2 equals y squared plus 4 over y plus 2y minus 2. All right, now I'm ready to multiply by my common denominator. The common denominator here is y plus 2y minus 2. So I'm going to multiply everything by that common denominator. All right, so in each fraction, we're going to cancel out the denominator. Y plus 2's cancel out, and I have 2 times y minus 2. Y minus 2's cancel out in this middle fraction, so I have y times y plus 2. And the y plus 2 and the y minus 2's both cancel out, so I have y squared plus 4. Okay, now we got to solve this equation. So I'm going to distribute on the left 2y minus 4 plus y squared plus 2y equals y squared plus 4. Sorry for switching colors. Okay, so what I notice is the y squareds cancel out. And I'm going to combine like terms here on the left. So 2y and 2y gives me 4y. So 4y minus 4 equals 4. If I add 4 to each side, I get 4y equals 8. And I'm going to divide each side by 4, so y equals 2. Now, check to see if your solution works. If I plug in 2, this denominator would be 0, and this denominator would also be 0. So I've got fractions here that are undefined. We cannot have that. So you rule out 2 as a solution, and there's no solution to this equation. Okay, I'm going to show you a couple more. The next one is 17. 17 is very similar to 16, so I wanted to show it to you. First thing we should do is factor this trinomial. So two factors that multiply to negative 4 and add up to 3. Well, that would be a d plus 4 and a d minus 1. Now these factors are close to the other denominators, but again we have this minus 1 minus d. To fix that, if you want to make it d minus 1, you simply add the opposite and you change it into d minus 1. Okay, so now I'm going to multiply by my common denominator, which is d plus 4 times d minus 1. d plus 4 times d minus 1. Every term in the equation needs to be multiplied by the same thing. Okay, and now I can cancel out each denominator. So in the first fraction, d plus 4 cancels out, and I have 1 times d minus 1. Equals, the d plus 4 and the d minus 1s cancel out in this fraction. I just have 2, what's left on the top, plus d minus 1s cancel out, and I have 1 times d plus 4. So by canceling out those fractions, we get a pretty easy equation to solve here. Now, what's going to happen? Well, I have d minus 1 equals d plus 6. If I subtract d on each side, they both cancel out. And I get negative 1 equals 6. Well, we know that it doesn't equal 6. And so what that tells us is that there's no solution to this problem either. We canceled out d on each side. Negative 1 does not equal 6, so there's no solution. Now, let's say you would have had something that was equal, like negative 1 equals negative 1. Well, then you would know that for any value that you plug in for d, all real numbers would work. Okay, last one is 22. I'm not going to solve this one for you, but I'm going to help you set it up. So this was a number theory problem from your textbook, so I'm just going to read it to you, and then I'll set it up. The ratio of 16 more than a number to 12 less than that number is 1 to 3. What is the number? We want to set up a rational equation here. So the ratio means a fraction. The ratio of 16 more than a number to 12 less than that number, so it's the number minus 12, equals 1 to 3, so 1/3. Now you need to solve this equation. Okay, one way to do it, just so you know, instead of canceling out the denominators, since you have a proportion here, could you not just cross multiply? Think about that and see if you could figure out what x is in this problem.